All right, I think we'll get started. So this is EMU working group at IETF 114. You have probably all seen this note well quite a few times this week, but it's up here again so you can refresh your memory. There's a couple things to go over. One is people in the room should be logged in through the on-site app so that the attendance is taken and so they can join the queue. Okay, so please log in through that app. There are some barcodes around, or you can go to the agenda and click on it. Other things is in the room, please wear a mask except when speaking at the microphone. Okay. So we have a pretty full agenda, but I think we should have time to get through all of it and maybe have a little time for some discussion at the end. One thing I would like to do is recognize that Mohit stepping down as chair due to additional responsibilities from his professional job. I want to thank Mohit for all the work he's done over the past couple of years and being a great co-chair. But now we also have Peter stepping up as a co-chair. I want to thank him too for taking on that responsibility. All right. Does anybody have any modifications they'd like to make to the agenda? All right, so I think we'll get started with TLS-based EAP types. So, Alan, do you want me to share the slides, or do you want to run the slides from your?
No, go ahead. Let me just go ahead, show the slides. Yeah, so not a lot up from last time. Go to the next slide. So we seem to be good to go. The document is okay. I haven't heard of any implementation issues other than implementation choices. So I don't want to name names and embarrass people too much, but one implementation has decided to not support new session ticket for TTLS and PEEP and presumably everything else. And the configuration for that does not always work. And I've seen questions about this. That's apparently on their agenda to get fixed, but it's one of these, decisions above other people's pay grades. The downside for supporting new session tickets or not supporting them is you have to do a full round of authentication every time someone re-authenticates. This can cause significant loads on back-end databases, especially in university settings where every hour you have 20,000 people closing your laptops, walking across the hallway, and opening your laptops again. However, if you can get these things working, the protocols do work, they interoperate, everything else seems to be good to go. And there's multiple client and server implementations. So that really is it. We had a bunch of reviews from various people. All of those have been addressed in the latest revision of the document. There might be a couple minor typos, but I think we're pretty much done it at this point. And that's hopefully finished and perhaps ready for a last call. I think that's it. I think there was only one slide.
Yeah, I think so. Thanks. Does anybody have know of any open issues in this doc? I think it's probably something that we can move forward. I don't know that we need to do another working group last call on it because I don't think the changes were that significant. But we'll go back and check and confer amongst the chairs, and then figure out what the next step is. But I think we're pretty much good to go with this one. I think we're about ready to put it through the.
Yep. I agree.
All right. Thanks. I think now Yari for IETF.
Okay, so this is an update on this forward secrecy draft. New version has been posted. Next slide. Yeah, so draft status has been fairly ready, in my opinion, for some time. Module 1 discussion about encoding of graphic values. We'll talk about that in slide 4. I guess the authors at least believe that there's an opportunity to deploy this and gain significant security improvements, particularly against some pervasive surveillance activities. If you get some of the keys, then that's really bad. But this specification can help there to some extent, at least. For the newest version, John joined us as one of the co-authors in the draft, and we improved the draft in a number of ways. We talked about that on slide 3, and then we went through, on our side at least, the background with regards to the current choice of encoding, and that of course is indeed on slide 4. And my wish is to start the working group last fall. Now we're ready for that, I think. Almost regardless of what discussion there might be, unless there's something drastic that we haven't heard of before. Next slide. So the other changes or other topics beyond this encoding issue, we attempted to further improve the explanation of what does this actually provide in terms of security benefits. We attempt to also say that this is that it's important to migrate the existing systems to use the forward secrecy method, and we make a recommendation to do this migration. We changed the wording a little bit with regards to how we refer to issues within the smart card. So we used to say like, there could be issues with smart cards, but it's rather not just with the smart cards, or maybe not even with the smart cards at all, but rather the supply chain, how you manufacture them and how you supply the keys forward and so forth. So trying to be accurate there. And we discussed a little bit about the chosen algorithms. Next slide. So in the last couple of IETFs, we've had some discussion about the public value encoding, and so we went through the discussion. We looked at the references, we looked at some other systems, and some open source cryptographic library implementations. The text by itself in the draft hasn't changed. So the text is in this box on the right-hand side. We did check the language in our specification in contrast to what is being said in the various references. We think it's exactly right. Of course, we could miss something, but hopefully you'll tell us. We'll also observe that this exactly same arrangement, the same lengths and so on, is used by the 3GPP 5G specifications for another purpose where they use this particular public key technology. And given this background, we'd like to keep the current text and move forward. So this is sort of aligned to what is anyway done in the phones, and that was a strong reason for us to keep it as it is. There are other alternatives, and they might even offer some benefits, but also perhaps some downsides. So for instance, we could allow both compressed and uncompressed forms, which is allowed by SEC 2. But that would, of course, introduce, maybe additional negotiation or issues with, like, you have to support both and so forth. So maybe not actually worth it. And yeah, so I guess the main question here, if anybody objects, and I don't know, John, do you want to add anything? Did I miss anything? John says no. Okay, so that's what I intended to say. Now, please, if you have objections or other observations or whatever comments, please come to the mic. And if there are no comments or objections, then maybe we actually are done, and you guys can start the last call, and then we hopefully get some additional reviews and maybe discover some further issues. I think that's the next step.
Yeah, I think we'll start the working group last call soon after this.
Thank you.
DPP is next.
Okay, thanks. My name is Dan Harkins, and so this is a document that Owen and I have been working on. It's in its 5th revision. Next slide, please. So to remind everyone, this is intended to solve the onboarding catch-22, which is that you need a credential to get on the network, but you need to get on the network to get a credential. So how you solve that has been pretty much well solved for Wi-Fi with the DPP protocol. So what we want to do is reuse the DPP bootstrapping mechanism and the ECC key pair format that it proposed, and use that to onboard devices onto wired networks. We want to use HKDF to drive a pre-shared key from this bootstrap key, which is actually a public key. Then do its insert-based auth with external PSK, addition to TLS, and do raw public key authentication from the client side using the bootstrapping key. The nice thing about this is that we're not proposing any new TLS extensions or changes, which we have been doing in previous versions. Next slide, please. So the big change from draft 4 to draft 5 was we had been using a draft from the TLS working group, extensible PSKs, but that doesn't really look like it's going anywhere, and we didn't want to hitch our wagon to something that's not really moving. And we were told that the best way to do this was to use the TLS external PSK importer draft, which is trying to canonicalize the way you import a PSK, much in the same way that there's exporters that you can take secrets out of the TLS context and secrets in. So basically, we used that specification to define how we can take this bootstrapping key. We use HKDF to produce the ePSK and the PSK ID, and then we construct the imported identity per the spec to use this ePSK and ePSK ID, and import it into the TLS key schedule. Next slide, please. So this is how TLS would look like using DPP bootstrapping keys. So the text that's not bold-faced is just your typical plain Jane TLS exchange, and the stuff that's in boldface is present if you're doing DPP bootstrapping. So what's going on is the client saying we want to do authentication using the server's going to have a cert, and we're going to add an external PSK. The client's going to authenticate with a raw public key, and then you define what the pre-shared key is using, again, this importer's construct. The server responds in kind, and then we just do the finished messages, and voila, they're good to go. So again, the only real change we did between 3 and 4 was where the arrows show the pre-shared key being added. This is now using the external PSK importer proposal. Next slide, please. So then how this fits into EMU is the proposal is to use this to authenticate T. So the device will basically plug into a switch, we get a deep identity request, and he responds by saying TLS proof of knowledge, in which case the server knows that he's going to be doing this DPP authentication. And then TLS will be authenticated using DPP bootstrapping. Once TEEP has been authenticated, it can proceed to the normal PKCS 10.7 exchange that's already part of TEEP, and now the client has a certificate, and his subsequent connection will be using that provisioned certificate. Next slide, please. So as I said, this is the 5th version of this draft. We do have some running code that Owen wrote. I'm working on trying to get this to work with OpenSSL. There's a new 7250 PR for OpenSSL that I'm going to try and take advantage of once that gets released. But we only have one implementation of this so far. We have gotten some good reviews from the TLS working group. Again, earlier proposals for this required new TLS extensions, and it required changes to the TLS key schedule, which made everybody nervous. So when we presented this at IETF 110, we got some very good advice from people at the TLS working group to use 8773 and 7250 instead, which was a great recommendation. So we did that, and then we got some more review in 111, and then finally in Vienna we were told that we should probably not use the we should probably use the PSK importers and not the old method of naming PSKs. So I think we've got a very good amount of review. Again, this doesn't require any changes to TLS. There's no new extensions. There's no change to the key schedule. This is all using existing RFCs and a soon-to-be RFC. It's still a draft, but existing proposals that have gotten good vetting. So again, the only thing that changed was we're using this external importer. So I'm thinking that this draft is pretty stable, and I'm hoping that we can get a consensus call out of this meeting.
Okay, does anybody have any questions or comments relating to this draft?
Thinking about the client identity protection, can you confirm that the PSK is only used once? Is that the case?
Yes.
Yeah.
Once it gets onboarded, it now has a certificate, and then the bootstrapping key is never used again.
Yeah. Then it would be good if you added some sentence about that, because that's a problem with TLS PSK, that you don't, if you reuse the PSK, you don't get any identity protection.
That's a great suggestion.
Yeah.
I will add that. Thank you.
Hazel?
Hi. When you say it's never used again, I assume you mean unless the device is reset and needs to be repaired to a network again, or is this literally once ever?
Unless it goes like reset the factory defaults, then I guess it could probably conceivably use its bootstrapping key again. But this is basically just a one-time get me on the network.
Okay, I just thought I'd ask in case that had any implications.
Okay, thank you.
Ira?
Yeah, I just wanted to point out what Jonathan Hamill already did, that RFC 9258 is the external PSK importer. It's published.
Oh, excellent. Thank
So relative to your rough consensus, I'd say it's pretty much. Sorry about my echo.
Great, thank you very much for that information. Again, so yeah, so that means that we're just using standard RFCs that have been vetted pretty solidly. So not doing any weirdness.
And I think this also fits into the charter. We have a charter item for bootstrapping key material or credentials. So I think we should start the adoption call and after this IETF.
Okay, thank you.
Now we have EAP ad hoc. Did you want to run the slide, Stan, or I'm happy to do it.
If you can, I appreciate. Thank you. This is the next version of this proposal for EAP ad hoc. A couple of co-authors joined this new version, Goran Sander and John Matson, who are co-authors of ad hoc as well. And in this new version, we have performed a full review of the document, addressing, I think, all of the concerns that were posted in the mailing list. So next, we can proceed to see the summary of everything that a highlight of the most important aspects this new version has addressed. So we can start in the next slide with a bit of a refresh, a recap. So basically, this method proposes the use of ad hoc, which stands for ephemeral Diffie-Hellman over COSI. Ad hoc provides a very compact and lightweight authenticated Diffie-Hellman key exchange with ephemeral keys. Provides mutual authentication, forward secrecy, and identity protection. And what's one of the most interesting things about ad hoc, I think, is that it's very suitable for constrained scenarios. So having an EAP method using ad hoc would provide a very constrained and minimal EAP method that could be used in constrained scenarios. In here, we can see one of the main changes we highlighted in this version is the use of privacy-friendly response identity. Sorry, and we can see that the main exchange would take care of about 6 messages. So it would be 6 messages that are also very expected to be constrained, not very long. And after the hook exchange, we would just provide the success indication if everything goes okay. So the next slide, please. This is one of the main highlights in this version, which is the use of the privacy-friendly response identity. So we have added a requirement to avoid permanent identifiers in clear text in the response identity. And we added using NIE a recommendation to omit usernames or similar. And here we can see some examples. We could just use at realm or anonymous at realm or an encrypted identity. So this way we would be compliant with privacy-friendly response identity. Next slide, please. So another item that we address is fragmentation support. To do that, we actually use a very similar method as the one used in EAP-TLS, which is adding some flags to steer the fragmentation either from the request or the response part, okay? And basically the workings are exactly the same as ETLS, so I think there should be no issues on how fragmentation is managed in this case as well. Next slide, please. Another issue that we are addressing here is using an alternative success indication in ad hoc. Actually, what we are using is the message for, which is already present in ad hoc. Although in ad hoc is optional, for if ad hoc, we are stating that it should be mandatory to use to be compliant with the alternative success indication. And next slide, please. And basically, we also added different error use cases, okay, for when the error is generated on each of the messages from ad hoc. So the idea is that anytime a message is not processed correctly, it would be followed by an ad hoc error message, which contains the following information. And we will be signaling the error to one of the other parties. Okay. Next slide, please. So basically, in this version, I think we addressed all the issues that were raised in the mailing list. We would appreciate any review from the working group. We do not expect a lot of changes or major changes, because ad hoc is already, we think, a very mature draft. Okay, and we would like to raise the question to the working group: is this work is ready for adoption, or could be adopted by the working group? And that would be it. Thank you very much. The questions.
I'd like to get a measurement of how many folks in the chat and in the room have read this draft. So you could raise your hand or indicate in the chat if you read this draft. Anybody in the room? One. Hey, Goram, do you have a comment? Or you just...
Well, I'm a co-author, so I obviously have read the draft. Can recommend it.
All right, I think we'll want to see a little more review and perhaps discussion on the list of this draft. I think we'll also have to evaluate, and it's not clear to me if it's within the charter as it stands, which isn't necessarily a problem, but we might have to amend the charter to take something like this on. But if we have support for it, so I think the appropriate thing to do here would be to have some discussion on the list, make sure that we have interest, and then we can discuss kind of an adoption and maybe work with Paul to see if it's appropriate to also amend the charter.
Okay, thank you very much.
Yeah. Okay, now we have deep onboarding.
Okay, I'll talk for this too. So we presented this. Michael and I presented this in Anima on Monday. There was a resounding chorus of "aha." So the question for this partly is whether this is applicable to Anima or here. There is some overlap. So if we go to the next slide. What we're trying to do here is solve a Brewski onboarding problem. So you have an unconfigured device, it needs to be onboarded, it has no credentials, would like to use unauthenticated EAP TLS and join a captive portal network. Well, 5216 allows for unauthenticated EAP TLS. It offers no additional help. And so effectively, this has been entirely unused and unusable. So the proposal here is to add explicit signaling via an NAI, EAP.ARPA. This can't be forwarded or proxied. It's a signal from the client device that I want a captive portal. Once it's on the network, it has a full network, full IPv6, v4, whatever. And this avoids trying to stuff Brewski into EAP and reuses existing captive portal infrastructures. Next slide. So the device can still authenticate the server, the subject alt name. If the CA route is good enough for web surfing, it's good enough for this. The behavior of the local network is really a bit to be defined. We can also use add.ARPA to signal other things. There's similar work being done elsewhere. The Wi-Fi Alliance has defined their own vendor-specific EAP TLS type, which does unauthenticated EAP TLS. This is part of the Wi-Fi Alliance Hotspot 2.0 captive portals. So something vaguely resembling this is widely deployed, not defined in the IETF, defined in an SDO, controlled by the SDO, and unusable by anyone outside the SDO. So this pulls some of that back into the IETF and lets people other than one SDO use it. I think that's it. Next slide is just questions. Oh, related work, yes. Similar work is being done elsewhere. And then the next slide is just questions. I'm done.
Good, Marcus. One question, you say this is based on things from the Wi-Fi Alliance. Does that mean that there's any IPR concerns with this?
Sorry, it's not based on the Wi-Fi Alliance, but the Wi-Fi Alliance has previously done something similar. And Dan may have comments. I don't know, do you have a related comment, Dan, or is it something else?
Something else.
Okay, yeah, I don't know what IPR the Wi-Fi Alliance has on this, given that 5216 defines unauthenticated EAP TLS, and we're just using this. I would hope that there isn't much, and Hotspot 2.0 has all kinds of other stuff that we're not doing here, but I'll go take a look.
Can you go back a slide? Jesus. Maybe one more. That one, there we go, yeah. So that's kind of a bold statement that a CA route is good enough for web browsing, it's good enough for onboarding. You know, CAs are supposed to do some due diligence before they give out a cert, and that due diligence that they do for serving up a web page, you know, that you're a legitimate entity to serve up a web page is not really quite the same as the due diligence that it should be doing to show that you're the legitimate owner of, or, you know, service provider of a particular network. I know that a lot of times the client just doesn't care, and while CAs do give out certs for web browsing, they don't really give out certs for onboarding, so there's a desire to, you know, just do it. But I think you should, it's kind of it's comment bait, right? If you make a statement like that in the draft, I think you're just going to get crapped all over. So I think you know, if you want to use the reuse / misuse assert, you should probably come up with a better reason than just that. Thank you.
Sure. Those are all good points. So part of the reason for saying this is there's an additional bootstrapping problem of if I'm going to connect to an unauthenticated network, it would be nice to be able to authenticate it, right? And in the absence of an existing CA, you really have no way of onboarding yourself and trusting that network without just simply trusting anyone. That seems to be rather a lot worse than leveraging an existing CA framework. That being said, CAs do not issue certificates for onboarding. They also don't issue certificates for EAP. And there's been, shall I say, some discussion about this topic. As best I can tell, the CA forum only allows CAs to issue certificates for use with HTTPS. That information is buried all over the place. So arguably using those certificates for email or EAP or anything else is a violation and, you know, should cause the certificate to be revoked and even perhaps the CA's authority to be revoked. So my sort of polite pushback, not really security pushback, but polite pushback is, if we're just reusing these CAs everywhere for everything, I don't personally see it as an issue here. And if it's forbidden here, it would be good to understand why it's not forbidden, or it is for EAP, for email, for everything else. But that's a bit of a larger discussion outside of this. So for the purposes of this document, it would be good to be able to authenticate the network you're connecting to, even if you don't authenticate yourself. And that's sort of the smallest phrasing I can have of that small set of requirements, I guess.
Bernard?
Hi, Alan. Just had a question about the EAP.ARPA. I'm a little bit uncomfortable with that because, you know, if you could use instead a username with the domain that you're looking to get to. I mean, are you saying that you basically have no idea what you're connecting to, so that you can't relate, you don't have an expectation about what server domain is?
So the EAP.ARPA here is the signal from the client trying to connect that it wants a captive portal network. If you use a normal domain and try to connect there, then what the server sees is, hey, user is trying to authenticate, but they've provided no client certificate with EAP TLS. They might be intending this to work in a captive portal, but that there's no explicit statement of, hey, I want a captive portal. And I have no identity because I just got bootstrapped and I have no idea what's going on, right? Brewski is all Internet of Things. So the EAP.ARPA is, I have no idea who I am. I want a captive portal and enough IP connectivity to do a whole bunch of other stuff.
Okay, so you don't even know who you're trying to connect to get credentialed. Okay.
Yeah, this is all Brewski, and there's huge amounts of stuff behind the scenes to bootstrap IoT things.
Which raises another question. If you don't know who you're connecting to, then are you going to sort of round robin through every single access point that you see from your scan? And your Brewski is successful?
Perhaps, right? This is really an issue independent of this for Brewski. 802.11u does say that the systems will broadcast the domains they can authenticate for. So if only one broadcasts eep.arpa, then presumably that's the one you connect to. And if multiple do, yeah, you don't really have a lot of choice, even in normal Brewski, to do anything other than sort of round robin.
Hendrik?
Yeah, maybe I can add something. Brewski has some own built-in mechanisms to, sorry, my camera is, so to authenticate the network you are connecting to. So the mother voucher communication provides the device some means of knowing whether it is supposed to authenticate to a specific network. So I guess Michael aims for using the ETLS just as a transport mechanism, and the provisional accept of the just further authenticated TLS to later on verify that the device is really onboarding to the network its manufacturer asked him to onboard to.
Yes. So the proposal here is this is simply a way to get internet connectivity. Whatever happens after that is elsewhere, defined elsewhere. Once you have full internet connectivity, you can do whatever you want to authenticate yourself, to authenticate the other side. Part of the pushback here for me is there's a lot of proposals to do basically everything over EAP. You know, if the only connection you have between the client and anything network is EAP based, there's a certain incentive just to throw provisioning, onboarding, PKCS7, everything into EAP. And as an implementer, among other things, that only seems wrong. It's complicated, it's fragile. The error paths back to the end user are almost non-existent. It's much, much better to use EAP just for EAP, and then you have full IP connectivity and you can do whatever you want. Question?
Yeah, so yeah, trying to think about this, like what's acceptable here, what the requirements actually are, and authenticating the server with the web CA routes, yeah, maybe. But what I was actually wondering about is that you see an SSID, let's say SSID example, and then you connect it and you think you want to do this, so you send a special identifier, and you talk to a server, and server gives you yeah, blah.com or whatever. And so is there some need to sort of correlate the two, that both the server and the client think that they are sort of connecting to the same network, or is there some reason why that's not needed, or it's not possible, or?
It would be good to have some kind of channel bindings. That's defined for other EAP methods, but not for EAP TLS. But yeah, that is a good point. And in terms of web PKI, this is what people do today for EAP, right? You get a certificate for radius.example.com from a well-known CA, and you drop it on your EAP/radius server, and you just use it. And depending on who you talk to, this is either perfectly fine or it will destroy the world. There doesn't seem to be a lot of in between, unfortunately.
So it sounds like we have, some questions here raised kind of on this how you identify the network, and whether that's important or not for this use case. And I think this would be an important thing to kind of resolve or at least expand upon if this is moving forward. What is your intention here? Are you guys publishing a draft or?
Yeah, we published a draft shortly before the cutoff. The current draft is basically a line in the sand of about 4 paragraphs. Let's do this. We will flesh it out and address all these concerns to the best of our abilities. And the question is, a lot of this is really done to support the Brewski work. So whether this is done in Anima or EAP, I suspect because it really, what we're proposing here really only involves changes to EAP, and any Brewski work is a second step. Once you have full IP connectivity, you just run all the Brewski protocols, and they don't even care how you got connected. So EMU would likely be the best choice for this, but the draft as it stands is really there to support Brewski.
Yeah. So one more comment. Wouldn't Brewski take care of the, you're on the wrong network problem? I mean, if you associate to this network, you get on the captive portal and you send a voucher, the mouse is going to go, oh, the voucher came through, foo.com, and foo is not where you're supposed to be. So I'm going to refuse this voucher request. So since Brewski should solve that problem, it would seem to me that your draft could probably even be simpler. Just don't even worry about authenticating the TLS connection for captive portal. Just do a completely anonymous unauthenticated exchange, and all you want is IP connectivity for the client, yeah. and Brewski should secure the rest of it for you, right?
Yes.
Okay, if there are no other questions, I think, we should keep an eye on this. Since you are reusing ETLS in maybe a slightly different way here, I think it would be important for us, if this moves forward, to kind of understand if that has any effects on other usages aside from this one. But seems relatively straightforward. But I don't know that I have any opinion on which group it should be done in necessarily. And I think with that, we are through our regularly scheduled agenda. Did I leave anything off? The other topic I had here was just to kind of discuss, are there things that we're getting through most of our chartered items. And as we see, there are a couple new ones coming up. For example, ad hoc, perhaps this onboarding use case that I think are not quite covered by the current charter. We've also had some discussion in the past on EAP as in general, if we wanted to look at making any sort of changes there, which seems rather, that's something that has been brought up. So I'd like to understand and I think also some folks have brought some things on how to improve the experience of EAP, getting associated with networks, et cetera. I think we're going to have to make a decision over the next, probably by the next IETF on what sort of things are we looking to bring into the group. So I want to understand if people have any thoughts on that now. And if not, I really would want folks to be thinking about that as we go forward. So if anybody has any thoughts, or also any other, since we have a little bit of time, chairs kind of, last couple of times we ran out of time with an hour. And this time, of course, we scheduled for longer and did not have as many presentations. So if anybody has anything else they want to discuss, you can take some time at the mic. Alan?
Yeah, I still have my other EAP document, which I think may still be interesting, based on feedback from various people, including Elliot Lear. I need to split that into discovery versus configuration. So in short, the proposal was put a couple more OIDs into certificates, and substantial amounts of EAP configuration become easy. There is something similar in the Wi-Fi Alliance that got pushed through based on Stefan Winter's work. And then the second part of the document is well-defined SRV records for discovering all this. So the theory for people who haven't seen the document is you should be able to say, I want to connect to example.com, and based on a couple of DNS lookups and web server lookups, you can get all your configuration for EAP, including CA server certificates, etc. So that turns the EAP configuration from something relatively complex to something fairly simple.
So is there any desire to do like another password-based authenticated exchange in EAP? So there's EPWD, which is unfortunately informational, and it's also unfortunate that it does the hunting and pecking version of Dragonfly instead of the hash to curve version. But since CFRG has produced CPACE from their PAKE competition, it might, if there's desire, it might make sense to have a EAP password that uses CPACE. Or does any, if nobody cares, then there's no point doing it, but I don't know.
Yeah, I haven't heard of anybody wanting to do that, but we will see.
Yeah, John, yes. I think Alan's two drafts here highlights the need for more guidance and maybe requirements on how to use certificates and certificate configuration in EAP. That's severely missing. So I think EMU should work at that in the future. Also, strong interest from to use EAP more in constrained radio networks. I think that's also something I think EMU should work on. And whether this requires a charter update or not, maybe Paul has to answer, but I think this should be worked on.
Okay. Yeah, I think we'll have to take some of this discussion to the list, but I think you know, those are some areas that I think we have proposals in and active, you know, people who want to work on that, you know, in terms of ad hoc and Alan's draft, and I think Jan Friedrich's draft also was along a similar line. So there may be something there that we could expand the charter to kind of cover. But I think we need to have a little more discussion. I don't know, Paul, if you have anything, but yeah. All right, if nobody else has any comments, I think we can adjourn early. Oh, Jan Friedrich.
Yeah, sorry, I didn't really manage to get my draft published before this meeting, so I'm still working on it. But I just wanted to get a heads up that I will publish a new version of my draft that I presented at the 113, the UTA draft, and I would be happy to receive any feedback also on if there's any implementation of EatNoob that I'm not aware of, because I'm still comparing EatNoob to my new version. So I will be sending to the list because I haven't received any feedback from since IETF 113.
Great. Okay. Thank you, everybody, and we'll see you online and at the next meeting.
Thanks. Take care.